Titan.
T-minus 40 seconds. Everything looks good for launch.
Larger than Mercury or Pluto, Saturn's Titan is the only other world apart from the Earth and Venus to have both solid ground and a thick atmosphere.
Titan, if it weren't in orbit around another planet, we'd have really no hesitation in calling it a planet in its own right.
We knew going that Titan was going to be exciting. Titan was a mystery hidden inside this hazy, smoggy atmosphere.
Cassini confirmed that Titan is shrouded in thick orange smog. Laboratory experiments have shown this could be the result of 4.5 billion years of sunlight reacting with the thick nitrogen and methane atmosphere. Cassini's camera could only see partly through the haze. The patches of light and dark looked like continents and oceans.
The picture we had of Titan before we got there was that it was going to be dark and eerie and cold. As dark as twilight is on the Earth, even at high noon, and you could be standing on a body the size of the Mediterranean, brimming with paint thinner.
For over 7 years, the European Huygens probe rode piggyback on the American Cassini spacecraft.
Give me an update by section only.
On Christmas Day 2004, it was sent on its way. Planet Earth never attempted to land on such a distant world before. With the Huygens probe on final approach to Titan, operations switched to European mission control.
The probe hurtled into Titan's atmosphere at 6 kilometers a second. The atmosphere would have been glowing violet around the probe as it decelerated.
Once on a parachute, the probe descended for the first 80 miles, seeing nothing but smog and haze.
As we got closer to the surface, down at about 30 kilometers, the surface features started to peek through the haze. Progressively, this landscape emerged of these bright hills cut by small dark channels that showed that there had been rain there at some time in the past.
The signal was taking over an hour to reach Earth. No doubt, Huygens was sending postcards from the edge.
There were just 20 of us in the office area where the pictures were delivered. It was dark in Germany, it was the winter. It really felt like we were out there gazing at this alien world that was just at our doorstep.
The probe drifted further, snapping these remarkable images all the way down.
We all kind of saw, our backyard in Arizona or the French Riviera, wherever it was you were from, you sort of saw some aspect of Titan that looked familiar.
They were everything that our images from orbit were not, because you could see a dendritic drainage pattern that looked like a river system, just like a river system would appear on the Earth. Boy, that was heady. That was like, ooh, it was like Jules Verne come true. It was just spectacular.
All of our paychecks.
Huygens landed on Titan. It sent back these few hundred pictures until the batteries died and the probe froze solid.
The probe landed with a thud on basically a streambed, an area littered with rounded cobbles that showed that these little rocks or ice particles had been tumbled around in a stream at some point in the past.
The whole thing just was very chilling, not in the sense of temperature, but just in the sense of what we were looking at. It was very, very alien.
It's not a place where you want to just jump out there in your shoes and socks and shorts and t-shirts. It's roughly 200 degrees Fahrenheit colder than dry ice.
With a surface temperature this low, nothing is what it seems on Titan.
Titan is a world with liquids. The difference is the liquid is not water. The liquid is methane. Think of gasoline. It's a liquid like white gas.
So you've got rivers of methane flowing on the surface. Anybody who's looked out of an airplane window flying over deserts and things like this say, yeah, I sort of understand what's going on the surface there.
Because it's so cold, water behaves like rock does and methane behaves like water does, but everything's just sort of shifted along the scale of volatility.
How do you end up with a landscape that looks so much like home on a world that's so different? At NASA's Jet Propulsion Laboratory, researchers are trying to determine how raindrops of methane can carve a landscape built from water frozen as hard as granite. Raindrop by raindrop.
So it's like rain on Titan, and we can see that when a drop is falling onto the ice, it just gets into the ice. It just disappears in the ice. Just incredible how much methane can be stored in the ice.
Methane soaks into ice like water into the ground. And just like on Earth, any overflow will cut its path downhill.
Titan would be a wonderful place to visit. Stand next to a babbling brook of liquid methane running by your feet, and I sometimes wonder, well, what would that sound like?
In fact, as we took radar pictures of other parts of Titan, we found even wilder things in the northern polar areas. There are entire lakes or even seas that looks to all the world like you could go take a boat and go to jet skiing or something, right? Up and down these channels there.
Titan is the only other place in the solar system that we know liquids exist on the surface. So here you have vast reservoirs of liquid natural gas, and oh, by the way, we have thrown in some ethane, which is a slightly more complex hydrocarbon, and oh, by the way, there's some propane in there. Everybody knows what propane is, so use it in your backyard barbecue.
Cassini's radar spied lakes as big as inland seas, even bigger than Lake Superior.
Imagine standing on the shoreline of what to you looks like an ocean of liquid hydrocarbons. That's gotta be pretty special.
And if you think the lakes are weird, try the volcanoes.
We think the material that comes out of Titanian volcanoes is a mixture of ammonia and water, which allows water to melt at a much lower temperature.
This is lava on Titan, a stinky mix of water and ammonia, molten at minus 150 degrees.
You can build anything from small cones to large mountains on Titan out of this stuff. If you were a visitor and you walked up and put your hand on a lava flow, you wouldn't burn your hand, you would freeze it.
In stark contrast to the cryovolcanoes and wet polar lakelands, bordering the equator are vast Titanian deserts, covered in dunes.
I think it'd be one of the 7 wonders of the solar system. What you'd see is almost unending sea of massive dunes, exactly the same size and scale of dunes that we see on Earth. Some areas where you see nothing but dunes for hundreds and hundreds of kilometers.
To make sense of what Cassini's radar sees, Ralph Lorenz makes the trek to the Australian outback. Not as far as Titan, but still a long way away.
One of the interesting things going on here in Australia is that there are linear dunes, which are the same kind of dunes we see on Titan.
You can go right up to a sand dune on Earth and dig in it, make a cross-section and see how the beds of sand particles line up to see how the thing formed under different wind regimes.
Comparing the pattern of dunes on both worlds can reveal the pattern of the wind on Titan. A clue to decoding the moon's complex cryogenic climate system. The byproduct of billions of years of production from the chemical smog factory in the upper atmosphere, the grains in Titan's dunes may literally fall from the sky. Like a rain of flash-frozen coffee grounds, they are swept by the wind into deep piles that cover 20% of the surface. And like a good coffee, these Titanian dunes are dark and rich.
The dunes represent a massive inventory of organic material, hundreds of times larger than all the coal, for example, on the Earth.
You're not likely to be hauling this alien coal home, but the liquid hydrocarbons lapping on Titanian shorelines could be very useful for the return trip.
There's more, let's call it fossil fuel type energy than we actually have known reserves on the Earth by a factor perhaps of 10 or even 100.
That's a lot of gas in anyone's language. But something even more valuable might be found among the storehouse of organic molecules. The answer to life, the universe, and everything.
How do you go from such simple material like carbon and hydrogen and oxygen and nitrogen to something which asks questions about where it came from? That's a huge leap. And on Titan, there's a real good possibility that some of those really difficult to understand intermediate stages actually occurred. It hasn't gone to completion, at least we don't think it has, although there are some people who think that if we go to one of Titan's lakes, we will discover Titanian bacteria that have figured out how to metabolize liquid methane.
Well, that's not a liquid that we, life forms on Earth like, but maybe a life form on Titan that grew up with liquid methane would be perfectly comfortable there and would look at shock at the thought that organisms would live in water. Oh my God, those things on Earth living in water. Pity those poor Earthlings. We live in liquid methane, much more pleasant.
Titan is the ultimate test for life in our solar system. If life exists under these alien conditions, then you might find it anywhere. It's the same story everywhere in the solar system. You'll never know what you're missing if you never go.